A crazy idea. That's what scientists called it when one researcher claimed that the coldest known world in our solar system was making itself even colder. Not by accident, by design of its own sky. For 8 years, nobody could prove him right or wrong because Pluto hides inside the heat of its own moon. 2 worlds, 1 signal, impossible to separate. Then, the largest space telescope ever built pulled them apart. The crazy idea was correct, and if an entire class of atmosphere stayed invisible to us this long, the real question is, where else are we still looking at 2 worlds and seeing one truth? Pluto, demoted, dismissed, filed away as a dead ball of ice, is running a kind of climate that exists nowhere else we have ever looked. An atmosphere that does the exact opposite of what every atmosphere is supposed to do. So keep this question in your pocket, because we will come back to it. If Pluto could hide something this fundamental right next door, how much of the outer solar system are we still reading wrong? Before the mystery, you need to see the world it lives on. In 2015, NASA's New Horizons reached Pluto after a 9.5-year journey. With only one flyby, it transformed a blurry dot into a real world. And the world it revealed destroyed the idea of a dead ice ball forever. A pale plain in the shape of a heart, smooth and strangely young, on a surface that should be ancient. Mountains of water ice rising more than 10,000 feet. Ice frozen so hard out here that it behaves like granite. Fields of nitrogen ice slowly churning in vast, lazy cells, as if something underneath were still moving heat. Surface temperatures between -387 and -369 degrees Fahrenheit, more than 250 degrees colder than the coldest place ever measured on Earth. And above all of it, layer upon layer of blue haze, glowing in the backlight of a sun more than 3 billion miles away. But here is what almost nobody tells you about Pluto. For most of its history as the 9th planet, we weren't even seeing one world. Until 1978, Pluto was a single smudge of light. Then, astronomer James Christie noticed that the smudge had a bump that moved. That was Charon, a moon more than half of Pluto's own diameter big, and discovering it rewrote Pluto overnight. For decades, we never once saw Pluto alone, and badly overestimated how big it was. Once we could see Charon, we could finally weigh the pair properly, and Pluto shrank. It turned out to be far smaller and lighter than the 9th planet was ever supposed to be. And Charon didn't just shrink Pluto, it revealed how strange the pairing really is. Charon is so large relative to Pluto that the 2 worlds are creating their own center of gravity, the barycenter. It sits in the empty space between them, outside Pluto's surface entirely, so neither one circles the other, known as a double dwarf planet. But being small was only half of Pluto's problem. In 2005, astronomers found Eris, another frozen world out past Neptune, slightly smaller across than Pluto, but around a quarter more massive. They had to make a choice, crowning a 10th planet, or admit that Pluto had never really been one. In 2006, the IAU finally defined what a planet is. Pluto failed one requirement. It never cleared its orbital neighborhood. It shares its lane with countless other icy bodies out in the Kuiper. So sharing a center of gravity out in open space is the exact same thing that blinded us to it. From Earth, it looks like 2 candle flames standing side by side, seen from miles away. Now tell me which one is flickering. That was Pluto and Charon in every telescope we owned. 2 worlds blurred into a single point of heat. In 2017, a planetary scientist named Shi Zhang at the University of California, Santa Cruz looked at those haze photos and proposed something that sounded backwards. On Saturn's moon Titan, haze traps heat and warms the world below it. Zhang argued that Pluto's haze might do the exact opposite, soak up sunlight high above the surface, and then bleed that energy straight back into space, faster than the paper-thin atmosphere could ever hold on to it. Colleagues called the idea unlikely. Some simply called it crazy. And for 8 years, it stayed exactly that, an idea. Because no instrument humanity owned could tell which world the heat was coming from. To feel how strange that idea really was, you have to see the rule it was breaking. Everywhere we have ever looked, an atmosphere works like a blanket. Venus wraps itself in carbon dioxide, and the blanket runs wild. Nearly 870 degrees Fahrenheit at the surface, hot enough to melt lead. Titan wears a thick orange haze, and even that haze warms the layers beneath it. Earth plays by the same rule. Strip away our atmosphere, and the average surface temperature drops by roughly 60 degrees Fahrenheit. Most of this planet freezes over. One rule, everywhere, a sky holds warmth in. Which means Zhang wasn't proposing a quirk. He was proposing the first world ever found where the sky pushes warmth out. And there was exactly one machine that could ever settle it. The James Webb Space Telescope doesn't fly past worlds and take pictures. It reads light itself, splitting it into its wavelengths until the light confesses what it touched. Which molecules, which temperatures, which world. Starting in 2022, Webb's mid-infrared instrument locked on to that faint double point of light, and for the first time in history, it split it in two. Here is Pluto's heat. There is Charon's. Two clean signals pulled apart after nearly a century of blur. And inside Pluto's signal, researchers found something that did not belong to the surface at all. The haze itself was glowing in infrared. In June 2025, a team led by astronomer Tanguy Bertrand at the Paris Observatory published the result in the journal Nature Astronomy. The haze is not decoration. It absorbs sunlight high above the ground and radiates that energy straight out into space, actively cooling Pluto's upper atmosphere. Roughly 30 degrees Fahrenheit colder than the models said it should be. Pluto is not just cold because it sits far from the sun. Pluto is cooling itself. Researchers now describe it as a genuinely new class of climate, the first confirmed planetary anti-greenhouse world. The crazy idea wasn't crazy. It was 8 years early. And here is your pocket question again, one size larger now. If the oldest rule of atmospheres could fail this completely on the very first world we managed to isolate, what else out there have we been reading wrong? But before we follow that haze, you have to understand how fragile Pluto's sky really is, because it doesn't even stay in the sky. Pluto's orbit is nothing like a planet's tidy circle. It's stretched into a long oval that swings from about 30 times the Earth-Sun distance at its closest to nearly 50 times at its farthest, so far out that a single Pluto year lasts 248 of ours. At its closest, Pluto actually ducks inside Neptune's orbit, briefly closer to the Sun than the 8th planet itself. And that wild swing does something to Pluto that happens on no other world we know. When Pluto is near the Sun, as it was around 1989, the faint warmth is just enough to lift nitrogen and methane off the surface as gas, and Pluto breathes out a thin atmosphere. But as it drifts back into the deep cold, that atmosphere begins to freeze, and part of it falls out of the sky as snow, settling back onto the ground it came from. Here, scientists genuinely split into two camps. One side says the atmosphere collapses completely, that as Pluto swings away from the Sun, almost all of its air freezes solid and drops to the surface, leaving the world essentially without a sky for part of its 248-year orbit. The other side says it never fully collapses. that a deep reservoir of nitrogen ice in a basin called Sputnik Planitia keeps releasing just enough gas to hold a whisper of atmosphere alive year-round. The strangest part, even as Pluto has been moving away from the Sun since 1989, its atmospheric pressure kept rising for decades, the opposite of what the simple freeze-out picture predicted. So we are watching a world inhale and exhale an entire atmosphere, and we still can't agree on whether it ever fully holds its breath. That same fragile, breathing sky guards a second secret. It's leaking. Pluto's gravity is weak, its atmosphere thin, and day after day, methane molecules drift upward, slip loose, and escape into space entirely. For years, nobody knew where all of that lost sky was going. The answer was hanging in plain sight. Charon. Charon's poles are stained a deep reddish brown, darker than anything else on that moon. And the mechanism is almost eerie. Because of Charon's slow seasons, each pole spends decades at a time in total darkness, a cold trap, with no sunlight to keep anything as gas. Pluto's escaped methane drifts across the 12,000 miles between the two worlds, freezes onto those dark poles, and waits. When sunlight finally returns, it doesn't melt that frost away. Ultraviolet light and cosmic rays smash the frozen molecules apart and weld the fragments into heavy red compounds called tholins, locked into the surface for good. One world is slowly painting the other with its own escaping sky, and it has been doing it since long before either of them had a name. In October 2024, Webb added another layer. A team led by Sylvia Protopapa at the Southwest Research Institute confirmed carbon dioxide and even hydrogen peroxide frozen onto Charon's surface, a chemical combination never confirmed there before. And Pluto wears its own history the same way. Along its equator stretches a dark region the size of Alaska, stained almost black by billions of years of falling tholins, organic molecules from the same broad family that may once have fallen onto the early Earth, helping lay the chemical foundations of the living world we know today. Nearby, in a region called Tartarus Dorsa, stand blades of frozen methane up to 1,500 feet tall, jagged parallel ridges carved by sunlight. A 2025 analysis suggests they may wrap around as much as 60% of Pluto's equator, a ring of knives circling an entire world. And then there are the two mountains nobody can fully explain. South of the heart, two huge peaks rise out of the ice. One about 13,000 feet tall, the other close to 20,000, with sunken summits and lumpy flanks that look like frozen floods. If they are what they appear to be, they are cryovolcanoes, mountains that once erupted a slush of water and ammonia from somewhere warm beneath the crust. And that word, warm, opens the quietest question of all. Cracks in the ice and a gravity anomaly beneath the heart hint at a liquid ocean, buried perhaps 100 miles down, sealed in darkness for billions of years. No mission is currently funded to go back and check, so that question simply stays open, and Pluto keeps its deepest secret. Hold the scoreboard for a moment. A sky that cools instead of warms, a moon painted by a leaking atmosphere, and possibly an ocean under the ice. All of it on a world we voted out of the Planet Club and filed away as dead. Now comes the part that reaches far beyond Pluto. Because Pluto's haze is not a one-off ingredient. Neptune's moon Triton carries a nitrogen atmosphere full of haze. So does Titan. If haze can quietly run a world's entire heat budget, then those worlds now have to be reread. Jung himself says their roles need to be rethought. And it gets closer to home than that. Before oxygen filled our skies, more than 2.4 billion years ago, Earth itself may have worn a haze of organic particles, while life already existed beneath it. Which means the strange chemistry falling onto Pluto right now may be the closest working model we have of the sky our own ancestors lived under. But the deepest cut is this one. Almost everything we know about planets around other stars comes from exactly the kind of measurement that fooled us here. An exoplanet and its star. Two lights blended into one signal read across unimaginable distance. We just spent decades misreading a blended signal in our own backyard. Two worlds we could name, on a map we could draw. So the question from the beginning is no longer about Pluto at all. Across a galaxy of blended signals, how many skies are we reading wrong right now? Hold that question and stand for one moment on Pluto itself. The sun above you is only a searing pinpoint, no wider than a pinhead at arm's length. Its light 1,000 times fainter than the daylight you know. The sky is a dim gray-blue gloom. Never fully day, never fully night. The ground is water ice at nearly 400 degrees below zero, so hard it would ring like metal under your boots. The nitrogen you are breathing in this very second would be part of the landscape here. Not air, but stone. And fixed above the horizon, never rising, never setting, hangs Charon, motionless, in the exact same spot for billions of years. This is the world that rewrote the rulebook. Not a giant, not a burning monster. A small, quiet, demoted world at the edge of everything, patiently doing something no world was supposed to do. For nearly a century, we couldn't truly see it. It was half of a measurement, a heat signal we couldn't split in two. It was hiding that the sky doesn't trap warmth, it throws it away. And the moment we finally pulled Pluto free, it handed us an entirely new kind of climate. Pluto didn't just get colder. Our reading of the entire outer solar system just got sharper. That reading is about to explode. Pluto sits inside the Kuiper Belt, a vast ring of icy bodies beyond Neptune, holding an estimated 100,000 objects larger than 60 miles across, and countless more below that. Only one spacecraft has ever visited any of them up close. Almost everything out there has never been seen as more than a dot. Right now, the Vera Rubin Observatory is beginning to survey that darkness, and it is expected to multiply the number of known worlds out there many times over. Maybe Pluto is not the strange one. Maybe self-cooling skies, leaking atmospheres, buried oceans. Maybe that is simply what worlds look like out there. And Pluto is just the first one close enough and bright enough to confess. The first example of an entire kind of world.